Okay, so this is section 1.3. We are working on a lot of properties for today. So if you haven't started to write the ones that are on the board, we definitely have a lot of writing to get to. And these are building blocks that are going to help us as we move forward. So we've already talked about order of operations and how those are important. We practiced simplifying expressions. Now we're going to work on identifying specific properties and applying those in problems. And we'll see that as we go forward. Two important properties to remember are going to be commutative and associative, and we'll talk about those definitions and some examples as we go forward here. So some vocabulary to think about. There are equivalent expressions. That just means two expressions that are the same. We have different identities. One of them is additive. We also have multiplicative, which has to do with multiplying. We have inverses. We already know what a reciprocal is. So these terms will all be used as we go forward. So keep these words in the front of your mind as we go forward. Now, the first things you need to start writing today are these four properties of equality. And basically, these are just ways of understanding how we can move numbers around and still have things be equal. These are useful skills to have to help us solve equations in any way they might be written. So we have first the reflexive property, which basically, if you think about a reflex in your body, a reflex is something that automatically happens. And so we can kind of think that this is very automatic to know that if we have some number, it's equal to itself, right? That just makes sense. That's an automatic thing. That is a reflexive thing, right? We don't really have to think about that. So 5 obviously would equal itself. If we have two numbers, 4 plus 7, of course that also equals itself, 4 plus 7 again. So reflexive tells us the number is equal to itself. So hopefully you have that one written down by now. Second we have is symmetric. So the symmetric property, if we look at our symbol definition that we're copying down, for any given numbers, a and b, if a equals b, then we can also flip those two around and say that b must also equal a. So if you think about what symmetry means, it's almost like a mirror, right? It's symmetrical. If you looked at the mirror image of something and flipped it around, it would still be the same. It's just written backwards. So if we look at an example, if 8 equals 2 plus 6, then we can flip the order of those and say that, put this second term first and say 2 plus 6 must also equal 8. So all we did was kind of flip those around, put the second term first and the first term second. So that's symmetric. So you have those two written down. The next one is transitive. So transitive, if you think about transitioning, it's moving things around. So given three numbers, if we say the first one equals the second one, and we say the second one equals the third one, then we know that the first number must also equal the third number. So let's look at an example of that. If you say 6 plus 9 equals 3 plus 12, and we also say that this term, 3 plus 12 equals 15, then we can also say the first one and the third one are also equal. 6 plus 9 equals 15. So basically, if you know that two numbers are equal to each other, if a equals b and c also equals b, then a and c must also be the same. So it lets you see that some third number is equal to what two other numbers were equal to, which we're given those. Substitution, which you've seen many, many times, if it allows you to replace something with what it's equal to. So if a equals b, then a may be replaced by b in any expression. So if you say n is 11, then anywhere there's an n, we can replace that with an 11, just like we've been doing in the problems we did last week. So substitution is not new. This rule is going to come up a lot. So now you have those four written. Moving forward, we also have a couple addition properties to talk about. So the first one is additive. So additive meaning addition, identity meaning something is equaling itself. So a plus 0, if we add nothing, then we get just a. So a ends up equaling itself. So really this just says if you add nothing, you get the same number. So 2 plus 0 equals 2. We obviously know that. This is just something to think about, and it'll be one of the reasons in steps in problems coming forward. So additive identity, you don't add anything, it stays the same. The additive inverse, whenever we hear inverse, that means opposite. So with addition, that means we need the opposite sign. So if you have some number a, you add that number a, but you add the opposite sign, you make a negative, then that whole thing added together will equal 0. That's the additive inverse property. So an example, 3 plus the opposite sign, a negative 3 will give us 0. That is the additive inverse property. A positive 4 and a negative 4 added together give us 0. Negative 4 would be the additive inverse of positive 4. So the opposite when you add. So we have those 6 things written down. Now we have just 3 more to talk about shortly. For the multiplicative identity, that just means you multiply and it's going to equal itself. Multiplicative meaning multiply, identity meaning equaling itself. So if you take some number and you multiply it by 1, it equals itself. Of course, you can flip those around and say the same thing. So that's your multiplicative identity. The multiplicative property of 0 is something we've known for many, many years. If any number is multiplied by 0, it will equal 0. So that the mathematical rule, vocabulary-wise, for understanding that is the multiplicative property of 0. Okay, so we'll have that rule come up as well in problems that we have to talk about. And the last one here is multiplicative inverse. So inverse meaning opposite, and we're talking about multiplying. So when we're doing multiplicative inverses, they should always come out to 1. Okay, notice if we go back, when we talked about additive inverses, they were talking about the number 0. Okay, so here we have additive inverse equaling 0. When we're talking about multiplying, the inverses come out to 1. So if you have some number, a over b, the multiplicative inverse is just the reciprocal. So you flip it. So b is on top, a is on the bottom. When you multiply them, all these things cancel out, and you just get 1. So here's an example. 4/5, if that's given, and you wanted to find the multiplicative inverse, you flip that. 5 is on top, 4 is on the bottom. That's your inverse. And if you check, when you multiply them, you get 20 over 20, which all cancels out to be 1. So you can do that with any number. So say you had 2, and they said, what's the multiplicative inverse? Well, you flip 2. So 2 over 1 becomes 1/2. So 1/2 is your multiplicative inverse because they multiply to equal 1. So that's it. So now that we have those properties, we can start getting into a couple examples. So first, example 1. We want to evaluate this expression given. We want to name the property used in each step. So first, we'll copy down that question and then talk about each step as we go through it. So we want to solve this, but we need to have a reason for each step that we do. And we can use any of the properties that we've learned, that we just discussed, as a reason for why we can justify that step. So if we look first, we need to do what's in parentheses first. We know order of operations. So we know 12 minus 8 is also 4. So we'll simplify that to 4. And what we really did in our expression is substitute. So we changed the 12 minus 8 to what we know it's equal to, 4. So what we did as our reason is substitution. The next step, we work with the other parenthesis. We take 15 divided by 5. We replace that with what it's equal to, 3. Now we also have 3 minus 2. We can simplify that one as well. We know that's 1. Again, we substituted a third time. So you should be writing out each step as we walk through here. Just replace the numbers. Now, if you go back here, we saw 3 times 1 when we simplified this, and we know that 3 times 1 is just 3. That's any number times 1 is going to be equal to itself, and the rule for that is multiplicative identity. So multiplying and you equal the same thing, identity, that's a multiplicative identity. So 3 times 1 equals 3. We can replace the 1. We can just get rid of it because we know 3 times 1 is 3. So that's what we did there. Now we look what we did. We had 1/4 times 4, and we know that 4 and 1/4, those are reciprocals, or they are also multiplicative inverses, because when they multiply together, they equal 1. 4 times 1/4 gives us 1. That rule is the multiplicative inverse. So we replace that, we write it there. In our last step, we add 1 and 3 together, we get 4, very easy. And the rule for that is just substitution, right? We replace this with what we know it's equal to. So substitution comes up a lot. And 4 is our final answer for example 1. Moving on to an additional rule, the commutative property. So commutative, meaning like commuting, is moving from one place to another. So the commutative property, given two numbers, a plus b, if they equal each other, b plus a, we can also say that a times b would equal b times a. So all we're doing is switching the order. Okay. We talked about the associative property. With the associative property, all you have to do is move the parentheses. So if you have three numbers, a, b, and c, you can also say that if you have the parentheses in the first two, that's the same as if you move the parentheses to the last two. And that works with addition and multiplication, because these things are interchangeable. You can change the order in which you do them. So 2 times 6 times 9 is the same as 2 times 6 times 9. Okay? So we have those two properties, and we also have the ones we talked about to begin with. All of these. So just a couple more rules to remember. Associative, we can associate the numbers differently and still get a same solution. So associative property, make sure you write that down. We'll pause the video if necessary to make sure we have time to do so. Now, real world example number 2. Very short, we have 2 sentences there to copy down. So Magina made a list of trail links to find the total miles that she rode. We want to find the total miles that she rode her horse given the information in our table on the right. So we have 4 locations and 4 distances given, and we want to use that information to understand how far she rode total. So all we really have to do is take the numbers given, all those mile distances tell us how far she rode to get to each place, and we can just simply add them all together. So if we add them all together, we write them in an expression. We know that addition is commutative, so we could write them in any order we want. If we put parentheses around the first 2 and add those, and then put parentheses around the second 2 and add those, we know we can do that because of the associative property, right? We can associate these 2 together and associate these 2 together separately, add them, and then add them their products at the end as the last step. So anytime you see parentheses being used, that's your associative property. If you just change the order, that's commutative. Okay? So we'll see some steps with that to help us. So when you finally add these, you replace them with what they're equal to. Anytime you do that, that is substitution. So we have those 2 numbers given. We add them together one more time and replace them with what they're equal to. That's substitution one last time. And now if we write our answer with our units, Magina rode a total of 27.5 miles on the trails. So the problem itself is not difficult. What we're working on is understanding why, though. Why are these things allowed? Why are we allowed to do these steps? And what rules do we know that we can say as justification? So example number 3, we can use multiplication properties to evaluate a given expression. So we have 2 times 8 times 5 times 7. And we want to use properties of numbers and name the properties used in each step. So we want to take this whole thing and make it equal to one number and simplify it. So let's start. We know we can rearrange and group the factors to make our calculations easier. So we can make them, we can move them in any order we want because multiplication is commutative. Commute meaning to move. Think about commuting to work. You hear that term tossed around, or commuting here or commuting there. It means to move. So we can move these things around any order we want. So it might be helpful to move the 5 in front next to the 2 because we know that 2 times 5 is 10. We can do that quickly in our head. Okay, so that's just something to keep open for ourselves. Also, we can group them into 2 separate multiplication problems because we might have these memorized in our head, so we can do those and then multiply their products at the end as a final step. So again, when you see parentheses, that is your associative property, right? We are associating 8 and 7 together. We are associating 2 and 5 together. Now we replace them with what they're equal to. So we know 2 times 5 is 10. We also know 8 times 7 is 56. So now we can multiply one more time and replace this with what it's equal to. That's also, again, substitution. So our final evaluating answer for example 3 is 560. And we wrote out our steps and our reasons why we were allowed to do those things. So you need the question, just a couple steps, and your solution is 560. These rules are the whole meaning of this section. So this is the part that we need to emphasize going forward. On the problems that you'll have to do for your homework, this is what's expected. You have to write the reason why, the property that allows you to make that jump, that step, okay? So now we'll move on to our assignment. Let me know if you have any questions, and make sure, again, our focus is on using all of these properties that we wrote down to begin with. Okay, so these properties are essential for all the math that we're going to do going forward this year. All of these properties. So if you're confused about any of those, make sure you get the help you need, and of course, make sure you have these in your notes and ready to go.